So what we're doing is a triple evacuation of the heat pump system. We're using a vacuum pump and a micron gauge, a manifold, and compressed nitrogen. And what we're doing is we're vacuum pumping it down to get the particulates and the moisture out of the lines. The micron starts registering at 9,000. We pump it down to 4,500, blast it with a little bit of nitrogen, pump it back down again to 1,500, blast it with some more nitrogen. Again, at that point, we close the system off, isolating and removing the manifold and the nitrogen, and just using the micron gauge and the pump, and we pump it back down to, now industry standard is anything below 500. We like it below 100. We find that it just cycles better, performs better, just all around just runs better at a lower number. So we let it get below 100. We get more particulates out of the system and out of the lines so that it just performs at a higher level.
And in layman terms, what does that all mean?
Just that when I go to release the refrigerant from the King valves, that there is no particulates and nothing else in the line, in the system, aside from the refrigerant that's going into it. When you have moisture and refrigerant in the same line, it creates an acidic environment, and thus will eat away the copper from the inside out.
Whoa. That sounds important.
It is very important. It is very important. You find that a lot of some installers and some companies don't do the proper evacuation. Industry, like I said, industry standard is anything below 500, and that would ensure that the particulates are very few. That when you release the refrigerant, we just like it below 100. We find that, like I said, it just performs better. It's a better system all around.
And why do you have to wait so long after the electrical work is done before you start the pump down process?
So the system has to be energized, not necessarily turned on, but just the breaker has to be turned on, the disconnect has to be turned on, power has to be going to the unit, essentially energizing it so that the compressor can warm up the oil that's inside of it. If you turn it on prior to that 12-hour or 24-hour, well, it's actually 12 hours by manufacturer standards, allowing the oil to circulate and be able to warm up, it could constrict it, it could not flow as well, and if you have problems with the compressor, you got problems with your whole system. So you want it to be energized for at least 12 hours with the power hooked up so that oil in the compressor can warm up. And we never, ever skip that. We don't ever, even on hot summer days, we do not try and skip that step and supersede that 12 hours and start it up early. You have to wait that 12 hours.
Because
Because otherwise you could cause damage to the compressor.